This video is regarding finding a particular solution of a second-order differential equation. The differential equation is y double prime plus 9y equals to 0. The general solution is y equals to c1 times sine 3x plus c2 times cosine 3x, and then we have two initial conditions, one for the y and then one for the y prime. So let's verify the general solution first. So we have y equals to that, and then y prime is equals to c1 sine of 3x. The derivative of sine is equals to cosine, so we have cosine of 3x, and then by chain rule, when you take the derivative of 3x, that is equals to 3, right? So we have a 3 in front of the c1, and then plus the derivative of cosine is equals to negative sine, so that makes the plus becomes a minus. So we have a sine of 3x, and then by chain rule, the derivative of 3x is equals to 3, so we have 3 times c2, and then there is a second derivative, so second derivative, and then c1, the derivative of cosine is sine, so we have sine of 3x, and then there is a negative, 3 times 3 is equals to 9, so these are chain rule. And then this will be a 9 c2 cosine x, and then you do the verify, so you have negative 9 c1 sine of 3x minus 9 c2 cosine, I wrote x, it is supposed to be 3x, let's correct that, 3x, so this one is my y double prime, and then my plus 9y, so y is given, the general solution, 9 times c1 sine of 3x, and then plus c2 cosine of 3x, that is equals to 0, so this is my y. Let me just, okay, I will just put the y right there. I'm trying to save some space. So negative 9c1 sine of 3x minus 9c2 cosine of 3x, and then plus 9c1 sine of 3x plus 9c2 cosine of 3x, that is equals to 0. So let me highlight the light terms for you. So we have a sine and a sine, right? So this is a sine, and then this is a sine, and then for the cosine, and then this is the negative 9, this is the plus 9, so equals to 0. That is verified. And then how do you use the initial condition? So to use the initial condition, so the first one, I will just do the color match. So y equals to 2, and then x equals to pi over 6. I will just plug it into the general solution because that is for y. So we have 2 equals to c1. We don't know c1 and c2 yet because that is what we have to find out. c1, and then sine of 3 times pi over 6, and then plus c2 cosine 3 times pi over 6, and then we have 2 equals to c1 times sine of pi over 2 plus c2 times cosine of pi over 2. So pi over 2, you have to record the unit circle. Pi over 2 is 90 degrees, so x is equals to 0, y is equals to 1, so 2, and then sine of pi over 2 is equals to 1, so we have c1 times 1, and then plus c2 times 0, so the c2 is gone, so this will be just equals to 0, and then we have a c1 equals to 2, so we have c1 equals to 2. All right, so that is for the general solution. And then the first derivative, what is the first derivative? The first derivative is y prime equals to 3 times c1, and then times cosine 3x, and then minus 3c2, and then sine of 3x. We already found c1, so I'm going to erase the c1 and then put a 2 in it. All right, and then in this problem, we will have to use y prime equals to 1 and x equals to pi over 6. So we have y prime equals to 1, and then 6 times cosine 3 times pi over 6, and then minus 3 times C2, that is what we have to find out, C2, and then sine of 3x, so that will be sine, forgot the sine of 3 times pi over 6, so 1 equals to 6 times cosine pi over 2 minus 3c2 times sine of pi over 2. So cosine of pi over 2 is equals to 0. 1 equals to 6 times 0 minus 2c2 and then times 1. So overall, we have 1 equals to negative 2c2, right? I changed the 3 to a 2. This is supposed to be a 3, this is supposed to be a 3, and this is supposed to be a 3c2. So c2 is equals to negative 1/3. All right, I got my c1 and c2. So now I am going to rewrite the first and the second derivative. So the first and second derivative, do you see that all the way on top we have y and double prime? So in case you are lost, so let me just follow my yellow dot. Do you see that? Y prime and y double prime on the upper left hand corner. So on the upper left hand corner, the C1 and C2, they are not verified yet. Let's do that right now. So I'm going to plug in the C1 and C2 to y prime and y double prime. So let me just do this return to green. So I'm going to say plug in C1 equals to 2 and C2 equals to negative 1/3 and then to y prime and the double prime. All right. So this one I have the y prime. So the y prime, I have y prime that is equals to plug it in. So that is a 3 times that. So that will be 3 times 2. So 3. It's hard to just go back and forth. Okay, I got an idea. I will just copy this. So copy, and then bring it down over here. So I don't need to copy this one more time. I can just do the replacement right here. So paste, and then make it a little bit bigger. I will just do the replacement right here. So let me erase the C1 and C2. So first of all, the C1 is now 2. Okay, erase, put a 2 in there. The C2 is negative 1/3. So that is negative 1/3. And then the C1, erase, put a 2. And then the C2, erase, put a negative 1/3. All right, let's clean this up. That is equals to 6 times cosine 3x plus sine 3x. The numbers are nice. And then negative 18 sine of 3x and then plus 3 cosine 3x. So now I got y prime and y double prime with the C1 and C2. So now let's check the particular solution. So we have this. And then what about my y? The general solution. Go up. Copy. Paste. And then what do I need to do? I will have to plug in the C1 and C2, right? So erase. Erase. What is C1? C1 in red, do you see that all the way on top? C1 is equals to 2. And then C2 is equals to negative 1/3. So I'm going to erase the plus as well. So that is negative 1/3. So is this still called a general solution? The answer is no. I should follow the color code, right? Although you might say that is not necessary. To make this look nice, follow the color code. So I am going to relabel this. It is no longer a general solution. Now it is called a particular solution. Because I figure out the C1 and the C2. Okay, how do you make sure that this particular solution is correct? How do you check? To check, we have to plug it in to the given differential equation. So the given differential equation is right there. Do you see that? Right there. At the very beginning, just look all the way to the top of your paper. So I am going to do this. Copy. And then paste. So I'm going to paste the image right here. So what is my double prime? My double prime is negative 18 sine of 3x plus 3 cosine of 3x and then plus 9 times y, which is in the box. That is 2 times sine of 3x minus 1/3 cosine of 3x. Overall, that is equals to 0 on the other side. Just distribute the 9. I know it is easy to see, but do it. Sine of 3x and then 3 cosine of 3x. Not next 3x. And then 9 times 2. 9 times 1/3 equals to 0. This should be extremely easy to verify. So first of all, I have a negative 18 and a positive 18, so they got cancelled. And then second of all, I have 3 and a negative 3, they got cancelled as well. So at the end of the day, we have 0 equals to 0. So that means the particular solution is verified. Then whatever is in the box, the particular solution, that is a correct particular solution. Okay, a lot of work, but it's a good experience. If you think my instruction is helpful, let me know in the comment below. You can like the video, share the video for me, appreciate your help. If you're on your way out, click the subscribe button for me. Trust me, it is worthwhile coming back. I will catch you all in the next lesson.